For question 4, what I did was I took y1 and y2 and plotted them here on this graph. First, I found the intercepts for the graph, which you can see through the following steps. For the first one, what I did was I just let y1 equal to y2, where you get x equals x squared minus x. We rearrange that and we get this factorial, which we can then factor out. We get x equal to 0 and x equal to 2, which is just shown here. Then for the y-intercepts, for the x squared minus x intercepts for y1, what we do is we just, again, do something similar where we just factorize the equation. We'll get x equals 0 and x equals 1, which is shown here and here. Next, what I did was I solved the area. So what I did was I turned this into a triangle, the right angle triangle here, which we can just use Pythagoras's theorem, which I'll show you later. And I'll also just solve the area to the right of that, just over here. That is done for the following 2 steps. So for step 1, we do area equals half base height, where base is equal to 1 and height is equal to 1, which is what we found back in these steps here. We then get the area there to be 1 on 2 units squared. For step 2, what we do is we take the integral of y1 plus y2 dx, which we then can rearrange. We'll get this equation here, and then we can then integrate, which we then get x cubed on 3 plus x squared with 2 and 1 to be subbed in, which is done here, which we again see equals 2 on 3 units. Now the area total for under the triangle is just both of these areas combined, half plus 2/3, which is approximately 7 on 6. The reason I wrote approximately is obviously there are still some small areas such as the one here, which we haven't calculated. But other than that, that's question 4.